All right, seventh grade, we're going to look at lesson 9.2 today, solving inequalities using multiplication and division. So here's what I want to do. I want to consider, oops, if my pen will work, 6 different similar inequalities and see how they are related to each other. So let's first look at 3m is less than 12. Remember, we're using the same process to solve inequalities as we used to solve equations. So if I want to get m by itself, I have to get rid of the 3. Since 3 is being multiplied by m, I'm going to undo that multiplication by using the inverse operation. I'm going to divide by 3. And I do that so that those 3's cancel and I'm left only with m. If I divide this side by 3, I also have to divide the other side by 3. So on the left of my inequality, I'm left with m, and 12 divided by 3 is 4. So here's my solution. M is less than 4. If I am going to graph this on a number line, then I need to put an open circle at 4, and I'm going to shade everything to the left of 4. And I'm going to use this open circle because my symbol is less than. It doesn't have the equal to part. All right, let's look at another similar problem. Negative 3m is less than 12. If I'm going to solve this inequality, I again need to get m by itself, so I need to remove this negative 3. Right now I have negative 3 times m, so the opposite of multiplying by negative 3 is to divide by negative 3. And I do that so that these will cancel, leaving me with just m. And if I divide the left side by negative 3, I have to divide the right side by negative 3. However, when I do this, my solution is m is greater than negative 4. Now let's consider one more example before we stop and talk about this. Let's say I have negative 2x is less than 10. And let's make it a negative 10. I'm trying to solve, so I need to get x by itself. So I need to undo this multiplication here. I have negative 2 times x. So to undo that multiplication, I'm going to divide. These negative 2's cancel. If I divide the left side by negative 2, I have to divide the right. So all I'm left with over here is x. And on the right side, negative 10 divided by negative 2 is 5. So take a look at my 3 solutions here, and hopefully you are asking some questions right now. If you look very closely on our first example, when we divided by a positive number, I had a less than symbol, and I ended with a less than symbol. But in my second 2 examples, you might be noticing that my inequality symbol has flipped. The only difference is that to solve this, I had to divide by a negative number. Anytime you divide by a negative number, you have to reverse your inequality symbol. So a less than becomes a greater than, and vice versa, a greater than would become a less than. So that's true when we are using division to solve, but we are using multiplication and division. So let's check out some examples using multiplication. Say I have t divided by 4 is greater than or equal to 3. Then we'll also compare that to t divided by negative 4 is greater than or equal to 3. And then we'll also look at x divided by negative 2 is less than 6. So let's start with our first inequality. T divided by negative 4 is greater than or equal to 3. I want t by itself. So the opposite of dividing by negative 4 is dividing by positive 4 is multiplying by 4. Remember, when you show your multiplication, use the dot, not an x, because that looks too much like a variable, or you can use parentheses. The whole reason I'm multiplying by 4 is to cancel this divided by 4. So that leaves me with just the t. And on the right side, 3 times 4 is 12. So my solution is t is greater than or equal to 12. Now let's also remind ourselves how to graph this. So I need a closed dot this time at 12 because I have the greater than or equal to symbol. This equal to part tells me to fill in this dot, and t is greater than or equal to 12. So I'm going to shade to the right. But let's look and see what happens in my next inequality. If I have t divided by negative 4, I want t by itself. So to undo divided by negative 4, I'm going to multiply by negative 4. And I do that so that these cancel, so that all I have left is t. Over here I have a positive times a negative, which gives me a negative, and 3 times 4 is 12. But you are noticing that I again had to reverse my symbol. I had greater than or equal to, but as soon as I multiply by a negative, I have to flip my symbol. Let's check that out in one more example here. To get x by itself, I'm going to multiply each side by negative 2, because that's the opposite of dividing x by negative 2. Those cancel, leaving me just with x. And 6 times negative 2 is negative 12, and I reversed my symbol because I divided by a negative. Let's finish graphing these just for extra practice. So in this case, if t is less than or equal to negative 12, I need a closed dot at negative 12, and I need to shade everything less than, so I'm shading to the left. When I have x is greater than negative 12, I need an open circle at negative 12, and it's greater than, so I'm going to shade everything to the right. If I come back up here to m is greater than negative 4, I'm going to put an open circle at negative 4 and shade everything greater, so to the right. And here I'm going to put an open circle at 5 and shade everything greater, so I'm shading to the right. All right, you are ready to check out your 9-2 worksheet, which is also in Schoology if you need to pull it up. Make sure that you solve and graph, and remember to reverse your inequality symbol anytime you multiply or divide by a negative.